Alright, so today we're looking at numerical data, and so what we're looking at is histogram today. It's one sort of way that we can display numerical data, and when there's a large amount of, or a large range I should say, it's often we would group them into groups. Excuse me. And those groups are what we call class intervals. So here's an example. So we might have something, hours that people work. And so we might put it in groups. We might say, okay, well, 30 to 34.9 is one group. 34.9, it should be 35, will be the next slide. And 39.9 and so on. So this time our groups so then we've got 5 groups there, whereas if we looked at individuals, we might have, a massive long line, which we're not really overly useful to us. All right, so then we might have the frequency. And so in this first group, we might have, say, 1 person. The next group we might have 6, and we might have 8, 5 and 3. Alright, so there's our information. It's in groups and class intervals, and we're now going to draw our histogram from that. So our histogram is similar to our bar chart, but with one main difference in that our columns touch each other. So for our histogram, we are going to label on our axes just the first part of each of those intervals. So the next one will be, that we haven't got, will be 55. So we're going to label 30, 35, 40, 45, 50 and 55. So I'll start here at 30, 35, 40, 45, 50 and 55. And that is our hours worked on that axis. So that's what whatever's up here, what this represents is hours worked. So that's what these numbers represent. Then up the side here we've got our frequency. and so now we have columns. So the first column is the first interval there, 30 to 34.9, and we don't worry too much about stopping it at the 0.9. We just keep our bar going up until the next one starts. So we have it like that. Then the next group, there's 6 in that, so we come up here to 6. So in this case with our histogram, here's the important bit. Each of those join up. So we transition from one, then into the next. Alright, next one is 8. Then 5. And then 3. So there's our histogram. Alright, and so we'll just write that. So the edges of our columns touch in the histogram. Alright, a couple of definitions of a couple of things. Alright, first one, mode. You can tell me what's the mode?
Most common.
Most common, yep. Most frequent, most common. Most frequent. And so it could be a single number, or as in this example, could be an interval. So the most common is the one with the highest bar on the histogram, and so it's the 40 to 44.9 that would be the mode. Right, so it can be an interval, could be a single number, could actually, if there was 2 bars at the same height, then it's both of those in bi-mode. Alright, another definition, that's range. You can remember what the range is.
The distance or the difference between the highest and the lowest value.
Yep. Okay, so the highest minus the lowest. Right, a couple other things about shapes of these histograms. Now, this histogram here, you can see the highest bit's in the middle, and then it's pretty even both sides. This one's maybe a little bit lower, but it's pretty even. So this one here you would say is symmetrical. Right. Here's the middle, each side pretty similar, therefore symmetrical. You could also have one where you get your highest down one end and then you got tails off, or highest down here, tails off this way. Or you could have another one where there's one right out here. So let's just write down definitions of what they might be. Alright, so symmetrical. Alright, so evenly distributed either side of the mode is what the definition would be. So here's your mode, then it's evenly distributed either side of that. And we've done a very good diagram. My middle bar's too wide, but you get the idea. So something looks something like that. Now, if it's not evenly distributed and there's a lot more on one side compared to the other, then what we term that is skew. So first of all, negative skew. So it has a tail to the lower or negative.
Does this apply to bar charts as well or not? Or we're not asking about that?
They don't, not bar charts, I wouldn't ask you about bar charts with skew. Because the bar charts, there's not necessarily any particular order that the categories would have to be in.
Yeah.
Whereas with a histogram, there's a definite order that
Yeah.
that your columns are in, from the lowest to the highest. So it doesn't really apply to bar charts.
Makes sense.
All right, so big tail or a lot towards the negative side. So you might have a column there, maybe a couple this side, and then the other side you might have a lot. Right, so seeing as we're always starting with our smaller numbers down there and our larger ones down here, so we've got this tail down here towards the lower or the negative end. Now positive skew's the opposite of that. Alright, so positive would be the tails up this way. Can't spell tail, nobody noticed that.
I did.
Got away with it.
Yeah.
I didn't even see that.
Oh, it just took me a while to work out what the word was. I didn't realise you spoke.
All right. All right, and so there's our histogram, what that would look like. is called an outlier. Can't spell that right.
A data value that's unusual to the array.
Yeah. Can't spell. Good thing I can do maths. Right, so yeah, it's one that's unusual, if you like. It stands out from the rest. And so in terms of...
Goes against the trend.
Goes against the trend, yep. So in terms of a histogram, might have something like this. Might have a histogram like this, and then you've got something all the way out here by itself. And so there, this would be our outlier. Okay. We all got that. Did you do log scales last year? Or this year, in year 11?
Do what, sir?
Log scales?
We do them in year 10. Didn't we?
Yeah. Alright, so one of the things this year, and there is pretty much always a question on one of the exams about this, using a log scale or a logarithmic scale. So for example, check out these numbers. So the numbers 0.001, 0.01, 0.1, 1, 10, 100, 1,000. So they're all numbers that all have something in common. And what they have in common is that they're powers of 10. These ones here are easy enough, powers of 10. 10 times 10, 10 times 10 times 10. Powers of 10. Those of you who do physics and that will recognise these. So this one here, which is 0.001, can actually be written as 10 to the minus 3.
Now what does that say, sir?
Can be written.
Okay.
This one here, 0.01, could be written as 10 to the minus 2. Oops. This next one, 10 to the minus 1. 1 can actually be 10 to the 0, index laws. You would have done in year 10, anything to the power of 0 is 1. 10 is just 10 to the 1, 10 squared, and 10 cubed. So these numbers up the top here, what we call them, well, what we would know them as is they're the powers. Now, this log, or the logarithms, so the powers, so the powers which are minus 3, minus 2, minus 1, 0, 1, 2 and 3, those powers called logarithms, so it's just another name. So they're called logarithms. And so, for example, by choosing this particular one, which relates to 0.1, what I can say then, that the log of 0.1, because 0.1 is 10 to the power of 10 to the power of what? 10 to the power of -1, so the log of 0.1 is -1. Now there's something I've not put in there that I really should have, is that 10. So it's log base 10. What's this 10? Well, this 10 is this number here. Now the good news for us is that we only have to worry about log base 10. We don't have to worry about any other bases. Those doing methods too.
Which is none of us here.
Which is none of us here.
Woo!
Is anyone doing methods in general?
No, not this
I
year.
don't think anyone is. Are
No.
they? This year there was a few, but I don't think actually.
Well, because if you're doing methods, this is just an easy class
Oh, this is an easy
to
2
take
units,
up
I guess.
time
Yeah,
and
I
then
guess that
get a
works.
good mark.
Easy 2 units. That works.
That's what I
Even if
did
you're not
though.
doing methods, it's still.
So in this
Still
course,
units.
we only use base 10. So we write log base 10 of something as just log without a number there of something. So when we're talking about logs, we're always talking about, in this course, base 10.
So on the exam, we should still write log base, like log 10 or?
I don't, it probably doesn't matter, but if you're worried about it, yeah, write that in this course. And it's also pretty well recognised in maths, even if you're not using log base 10, just log without a number there is base 10. If it's not base 10, then you put the number. So, all right. So, what if we do need to do some things? Well, we need to use our calculator. Let me get rid of all that stuff. Now, something else while I think about it, this clear all variables. Sometimes people's calculators start doing some funny stuff. I don't know why, but sometimes you can fix it if you do this clear all variables and then clear them all and then. So, I don't know why, but sometimes if you've been using your calculator for some functions, maybe it's left some stuff in there somewhere.
Does it just think it knows what you want to do?
Maybe it thinks it knows what you want to do, yeah, I don't know, but I don't know, lots of times people say my calculator's not calculating properly, and then you go and you do that and then it does it. Don't know. Don't know why, but I know that. So if sometime you think your calculator's not doing what it should, try that first, and then we'll... Righto, so, calculator. We'll look to that. It's on the main screen. So on our main. And then from the main, you open up the keyboard.
Is this still with log?
This is for the log. I'm going to show you where to do it. So on the keyboard. And now you'll notice on your Math 1 tab's your default. So Math 1 tab. And then there's a few things here. There's a couple of things up right over here with log. One of them's got log with a black box, and then another one, this one here's got log 10. So this is the one we're interested in. So when you click on that, again, I want to point this out to you so don't start to panic. This is how the calculator writes it, okay? So we go to the icon that's like this. And so when you do that on your calculator displays it as log 10, comma. So if we want to, for example,
What would a question look like that they would ask us that has this?
what would a question look like?
What would they be asking?
Let me think. It would probably would be something that would have a big range of stuff, a bit like this, the example I'm going to do in a minute. We've got a big range starting from, say, a small number to something into the thousands. So if you're going to draw a histogram, you'd have one that's, so then we use this base 10 to bring it down. So that's kind of what the question would look like. There's always a question, whether it be a multiple choice. I think this year there was a multiple choice one about a log, and one that's might have, like, that comes to mind, and you're told that this is a log scale. What does this represent? So on a log scale, this is a log of 2. What does that represent? Yeah, it represents 10 to the 2, which is 100. So that kind of question's something that they would ask as well. I know they've asked something very similar to that a number of times. Yeah, well, they'll put a log scale and ask you to calculate something, and then if you don't recognise it's a log scale and we've changed it to 100, you just write it down as 2, but you don't get the right answer. Alright, so if I wanted to calculate, for example, if I wanted to find the log of 45, all that means on the calculator it would be log 10, we're only talking about powers of 10. Then after that comma, you just put the number 45 in there. So I put the number 45, close my brackets, then go exe, and there it is. And there's lots of decimal places. I'll just put down 3. Another question that you could get would be, if we go on the other way, we're told there's a logarithm, so like this, for example. So find the number. So It says find the number whose logarithm is. So remember, logarithm is power. Okay, and so because we're working at in base 10, it's the power of 10. So in base 10, what that means is the logarithm is the power of the 10. So the logarithm, which is 2.7125, that's the power on top of the 10. And you'll notice somewhere, have we got it? No, they don't have it. So to do that on your calculator, you go 10, then that hat, 2.7125, 10, hat, 2.7125, I hope I got that right, yep. And there we go. So it's 515.822. All right. Let's do an example. Putting some of that together. So the example we're going to do is the one out of your book. Example 9. Text. Page 30, I hope. Yes. What do I do with the textbook? Bring it. That's right. So, page 30. Alright, so here's a histogram. Interpret this histogram. So the histogram shows the distribution of the weights of 27 animal species.
Well, I'll back in the
27 animal species, and there's our histogram. Let me bring it up. Let's bring it up here, shall we? That would make sense, wouldn't it? Further maths. What am I doing? No, that's not the textbook. Oh, there it is. There it is. Oh, hold on. There it is. This one, yes. Finally, there we are. So, the histogram shows the distribution of the weights of 27 animal species plotted along the log scale. Alright, so it says log body weight. So, this here, it's 3, it's not 3, but 10 to the 3, which is 1,000. So you get from some really light stuff to some really heavy stuff, like mice to elephants kind of thing. So if you didn't use a log scale, you would, so get something like this, you know, really light stuff, and then, so it doesn't really give you a good view of how things are spread out.
Because the higher the number goes, the more numbers there are in that bracket.
Yeah. Oop, I've gone past. There it is. All right, so, you know, this here, 10 to the 4, that's something that's 10,000 kilograms. Now down here is something that's a few grams, you know, less than a kilogram. So like I said, mice to elephants. All right, so what body weight in kilograms is represented by the number 4 on the log scale? So the number 4 is a log scale, the 4 is the
Power.
power. So the 4 is the power.
So it's 10,000.
Part A, the 4 is the power. So it's 10 to the 4, which is 10 times 10 times 10 times 10, which would be 10,000 kilograms. All right. So how many of these animals have a body weights that are more than 10,000 kilos? So again, you've got to connect this 10,000 kilos, because this is a log. What does 10,000 kilos associate with which of these numbers? And we've just figured that out, haven't we? That it's the 4.
So 8%
Which
of 26.
So it's,
27.
so here's our 10,000. It says more than, so it's this bar here, which was 8%. So we've got 8%. And it asks how many, doesn't it? It says how many, it doesn't say what percent, it says how many.
Divided by 27.
So how many? 8 over 100 times by
27.
27. So how many animals? What about the 0.16?
Yeah, that's around it. It's a whole number.
We would have to round it to a whole number when we can't have fractions of animals.
0.16 of an elephant.
Then how do they work that out? How do they get,
It's just a
That
random
number.
example.
okay.
They probably just pulled numbers out of a hat and hoped it worked.
Maybe they did. Correct. So we need to write it as equals 2 animals. All right. Part C says the weight of a cat is 3.3 kilos. Use your calculator to determine the log of its weight correct to 2 significant figures. All right, I'll get to this 2 significant figures bit in a minute. So its weight is 3.3 kilos. And we want to know the log of that. So the log of 3.3. So on our calculator, let's go back to our calculator. Remember, the log is this one here. What do we want the log of? We want the log of 3.3. And then you get that. So you get all of this long number. 5, 1, 8, 5, 1, 3, 9, 3, 9, 9. For all of that.
Last
Right, now, it mentions, where are we? In the book here, it mentions two significant figures. So it's two figures that are significant in the answer. So with significant figures, I've got a handout that I'll show you that goes into more details. But basically with significant figures, any zeros that are at the front, you don't worry about them. And then you count how many figures after that. Now they're saying 2, so we don't worry about that 0 at the front, we don't count that. And so,
Why are significant figures a thing?
It's funny.
what it has to do with, if you're doing science or something, what it would have to do with is your precision.
Why wouldn't round
So if you've got a precision of 0.1 of a kilo, and now we've got a precision of whatever, you can't be more precise with.
Like, Tom, in chemistry, like when you're doing the equations, so like calculating how much air is left over, you have to be precise about that.
Yeah, and you can't, after you've done your calculation can't be more precise than what your actual measurement was in the first place.
Is that,
Yeah.
is that
No, I
5
think
minutes early?
they've changed all the times.
I don't know, was that early or
Yeah, it's 50 now.
supposed to be 50? Oh, yeah, no, that's it, we're done.
Wait,
Well,
you got a
It's
new
supposed to be
timetable?
56.
Eh?
We're supposed to finish at 56, aren't we?
It says 51 here.
No, it's changed because we don't have mentor today.
You're
Yeah.
right.
We've only got
All
mentor.
right. So we will finish this example next lesson then.
So will we start to complete the questions now?
We'll do them next lesson too.
Okay. Sounds great.
To the following students, please hand their library books back. Glenn Taxi, Lachlan
Oh, yeah.
Gray, Kira Cleaver,
let me
Kim Ojovic, Alex